The first thing we do with any examination question is to read it carefully so that we understand what's required. It's a probability question about two combined events, A and B. And the first thing to note is that the first part carries 4 marks, the second 2, and the third 1. In other words, the first part is the most important part, and the other 2 will probably follow directly from the first part. Now, there are 2 ways of dealing with a question such as this. One is to use a Venn diagram, like that, and the other is to use the law of probabilities for combined events. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Or, in set notation, is using the symbol for union, and in set notation is using the symbol for intersection. Now that formula is in the formula sheets, so you don't have to necessarily know it off by heart. I will actually prove it later though. The second part, here we are, is about conditional probability. And again, we're going to use a formula that's in the formula sheet. The probability of A and B over the probability of A. Or the probability of B and A over the probability of A. Again, I'll prove that later. And the third part is about 2 independent events. We have to work out whether A and B are independent or not. And they're independent if the probability of A and B is equal to the probability of A times the probability of B. But all 3 of those have been worked out already, so it's a very simple process to go and prove that, decide whether they are independent or not. Again, I will discuss this particular law and prove it for you later in the question. I'm now going to do part A by 2 different methods, by a Venn diagram and then the use of the formula. I'll begin with the Venn diagram. And to begin, we use the information we're given that the probability of A and B is 0.1 and the probability of not A and not B is 0.2. So we're able to fill in 2 regions of the Venn diagram immediately. This must be 0.1 and the region outside, which is not A and not B, must be 0.2. That tells me that the total area inside the 2 circles must be 0.8. That's the total area, and we'll use that in an equation in a minute. Now, if we let the probability of A be x for simplicity, then we can fill in 2 other regions. This one, which must be x minus 0.1, and this one, which must be 2x minus 0.1. And as I said before, the sum of the 3 regions inside, those 3, must be 0.8. So x minus 0.1 plus 0.1 plus 2x minus 0.1 must be 0.8. We have a very simple linear equation. And connecting terms together, we will see that 3x is 0.9. Those 2 terms disappear, and that will join 0.8 on the other side of the equation. So x must be 0.3, and 2x, of course, would be 0.6. So the probability of A is 0.3. Now for the mark scheme for this question. You get an independent mark B1 for getting the Venn diagram right. I say for putting 2 intersecting circles and putting the 0.1 in the right spot. So there is an independent mark there of B1 and another independent mark for getting the other 3 regions correct. So there's another independent mark there. You get a method mark for getting the right equation over here. That is this equation. I say the right equation, it's for getting the correct equation from your Venn diagram. So you could lose one of the B marks, but still pick up the method mark if you correctly wrote down an equation, a correct equation from your Venn diagram. And finally, you get an accuracy mark for getting the answer. You can't get that accuracy mark without the method mark. In other words, if you just guessed the answer and wrote it down, you would lose 2 marks. But of course, if you do make a mistake with the Venn diagram, you could still pick up 1 mark, for instance, for getting the 0.1 in the right place, and then a method mark for getting the correct equation from your Venn diagram. Now let's look at part A with a slightly different method using the formula. We begin in almost the same way. We let the probability of A be x, and because we are told the probability of B is twice the probability of A, then the probability of B occurring will be 2x. Now we're going to need the probability of A or B, and we therefore have to use this relationship. The probability that A or B is 1 minus the probability of not A and not B. Now that formula is not given in the formula books. And so really you've got to visualize a Venn diagram where it's easy to see that the yellow region, which is the probability of A or B, is 1 minus the white region, 1 minus the probability of not A and not B. So in this case it will be equal to 1 minus 0.2, which is 0.8. We then come to the formula for combined events, which is given in the formula booklet, but again, as I'll show later, it's very easy to work out for yourself if you wish, so you don't actually have to remember it or go searching in the formula booklets. The probability of A or B, we've just shown, is 0.8. The probability of A is x and B is 2x, and the probability of A and B is given as 0.1. We get 0.9 is 3x, and therefore x, which is the probability of A, is 0.3. Virtually the same, but I believe that it's far easier to understand using Venn diagrams in the first place. Now we come to the mark scheme, and it's virtually the same. There is an independent mark there for using 0.8 or for getting 0.8. There is another independent mark for using 0.1 in the correct place in that formula highlighted in blue. And there is a method mark for correctly using that formula. And finally, an accuracy mark for getting the answer 0.3. And exactly as I said in the previous clip, you don't get the accuracy mark if you just write the answer down. You've got to show how you got it. So you've really got to show the use of that formula highlighted in blue. Moving on to part B, this is a question about conditional probability. We're asked to find the probability of B given A, and we need to use therefore the law of conditional probability, or the formula for conditional probability, which is given in the formula sheets. So you can quote it. You can also work it out for yourself, as I will show later. Actually, in the formula sheet, it's given the other way around, as the probability of A given B is the probability of A and B over the probability of B. So you've got to do a little transposition in your head to get this particular version of it. Now it's just merely a matter of substituting values we've already calculated. The probability of B and A we were given in the first place as 0.1, and the probability of A we just calculated as 0.3, so the answer is a third. Simple. Now the marks for that are as follows. There is a method mark for using your value of PA correctly in the form. In other words, putting the 0.1 in the right place and using your probability of A, which we hope is 0.3, in the correct place. And then there is an accuracy mark for getting the answer. As before, you can't just write the answer down. If you just wrote the answer down, you'd get nothing. And finally, the last part of the question, we're asked to determine whether A and B are independent events. We are only given 1 mark for it, so it ought to be pretty straightforward. And we require to use, if they are independent events, then the probability of A and B will equal to the probability of A times the probability of B. I will prove this for you later. We know the probability of A and B is 0.1, we're given that. We've calculated the probability of A as 0.3, and therefore the probability of B being twice the probability of A is 0.6. So we need to calculate the probability of A times the probability of B, which is 0.3 times 0.6, which is 0.18, which is not equal to the probability of A and B. It's not equal to 0.1. Therefore, we can make the conclusion that A and B are not independent events. Highlighted the word not. That's our conclusion. The mark scheme for this is quite simple. There's only 1 mark for it, and it is what's called a reasoning mark. So in other words, you get the mark providing you have correctly reasoned that they're not independent. So if you've made a mistake and got the wrong answer there, providing that 0.6 is not bigger than 1, providing, suppose you got, for instance, 0.6 for the probability of A, you would have a ridiculous answer of 1.2 for the probability of B. You wouldn't get the reasoning mark there. But providing your two answers correctly follow through, you will get that reasoning mark for getting the right answer. And now let us look at the law of combined events. Now, the demonstration of this law is in fact incredibly simple. If we add together the probability of A to the probability of B, what we have done is add this probability to this probability. And you will see that we have actually added this probability, which is the probability of A and B, we've added it twice. So all we have to do is subtract one of those additions, and we will have the probabilities represented by the yellow shaded area, in other words, the probability of A or B. Simple. And now let's look at the law of conditional probability. And I'm going to do this via a Venn diagram. So here I've drawn a Venn diagram of all the possible outcomes of 2 events, A and B. We have A and not A, and for A we have the possibility of B occurring or the possibility of not B occurring, and for not A we have similarly the possibility of B occurring or the possibility of not A occurring. Now, in fact, all I'm going to be looking at is this top branch here. The probability of A and B is the product of these 2 probabilities. So the probability of A and B is the probability of A times the probability of B given A. And we can rearrange that to the probability of B given A is the probability of A and B over the probability of A, or the probability of B and A. Write it the other way around. Same thing over the probability of A. And there we have the law of conditional probability as used in this question. You can, of course, interchange A and B. Just transpose them, and we have it the other way around. And that is the version that is given in your formula sheets. And finally, let's look at independent events. Now, if A and B, or B and A, it doesn't really matter, if A and B are independent, then what it means is it doesn't matter if you're given A or not given A, because B is completely independent of A. So if A and B are independent, the probability of B given A would be exactly the same as the probability of B given not A, which is just quite simply the probability of B. It doesn't matter whether you're given A or not, it doesn't change the probability of B. So we can rearrange this formula here, replacing the probability of B given A by just the probability of B, and we get the probability of B and A, or A and B, is the probability of B times the probability of A. In other words, two events are independent. If A and B are independent, then the probability of them both occurring is the product of their probabilities. I do hope that you have found this video helpful. If you look at my YouTube channel, there are other similar videos, all based upon a single A-level question like this. Many more are planned, so please subscribe to my channel in order to receive notice as soon as any new video is published. The word subscribe is actually a little misleading, as it is, of course, absolutely free, anonymous and without obligation. If there's a particular question that you'd like me to make the subject of one of my videos, email me the details and I'll consider it, though bear in mind it takes many hours to create each video. Alternately, if you like my style, we might be able to arrange individual online tuition. My credentials are as an A-level teacher and examiner with over 40 years experience. I also have a website where many other A-level questions are studied in great detail. Each lesson is based around a single A-level question, although there are graded exercises and interesting and often amusing extensions of the particular topic.